today we will continue our discussion on the model slicing. We have started model slicing in module 1, and let me come to the yes. Okay. So today we will continue our discussion on model slicing. How do we construct contours in your slice data. Okay, because uh, when we are saying slice data, it means we are interested to consider the data corresponding to a particular layer or slice. Okay, so in that particular slice data or a layer, uh, the all the lines, uh, line segment in the linked list, that is the data point which you are getting after slicing, are used to construct your contour. Okay. The facet normal of your of the facet normals determine the pointing direction of the line segment by the head and tail search method. Okay, so the head to tail search method is used to construct a contour. Like this is the point data. Suppose this is this is you are having the one diagram in the right hand side. If you can see, there may be lot of points inside these lines. Okay, and there is no facet in this particular portion. Like in this portion, there is no particular sliced point. Okay, data corresponding to your slice data. Okay, so we need to consider the data or the points which are under only the points which are which are in your slice. Okay, so in this slice, when we join all the points, we may get some shape something like this. Okay, so this may be some 2D profile corresponding to your one slice data. Okay, and from any point we can start head to tail search. Obviously, uh, because your facet normal will be representing the direction of your head. Okay, so this way we may construct your 2D contour corresponding to your layer. Okay, and in this layer, because this is the simplest case, when you are saying there are only one or two contour. Okay, one is your external contour, one is your internal contour. But in actual case, there will be thousands of contours in a slice layer. There may be a lot of contours in a slice layer. So how to group these contours, and how to decide which one is which one is your internal contour or which one is your external contour. And also we need to construct these contours in such a way that these contours are not intersecting with each other. If these contours are intersecting with each other, it means the contours are not constructed properly. Okay, so suppose when I was saying that there may be multiple contours, so I have taken one simple example. Let us see, we are having a 3D CAD model, something like this. Okay, and this is your build direction, or you can say the viewing direction, or the direction from which in which direction you will be printing your component, this particular component. So here you can see there are some external contour like this. Then there are some internal contours. This. Then again, on these internal contours, there may be external contour and internal contours. Okay. So yes, yes. Just a second. Okay. So here, what we can see in this when we are seeing the build direction, there may be there are contours like C1. Okay, so C1 contour is some rectangular box. Okay, Then on C1 we have these contours. These are named as C2, C3, C4, C5, C6, and C7. So these are the contours which are which are found when we are moving in the build direction, when we are moving in this build direction. Okay, so you will find these contours, like you may find uh, C2, C2 is there, C3 is there, then you may find C4, C5, C6, and C7. So you may find these contours like this. Okay, so the main issue is that you need to identify the relationship, that is the parent and son relationship, like uh, which contour is son and which contour is parent. Okay, and then how we will identify this parent son relationship. So for this we will be using hierarchy sorting, then we will be sorting these contours. Okay, so there are two types of sorting, that is the hierarchy setting. And in hierarchy setting, what basically we are seeing the parent and son list that defines the containment relationship of contour. It means that how these two contours are related with each other, like C1, how C1 is related with contour C4. Let me erase it. Okay. So how contour C1 is related? C1 is parent of, you can say, C4 or C5, C2, C3, C6, C7. Okay, C1 is it can be said the parent of all these remaining contours. Okay, because uh, it is a contour in which all these or ever which these contours are lying. Okay, and again or the vice versa, we can say C4 is son of C1, right? Something like this. Okay, so uh, first we will be focusing on hierarchy sorting, then we will go and on contour sequencing. We will try to understand what is hierarchy sorting, right? Yes. So in hierarchy sorting, what we have to do? Build a parent and son list that defines the containment relationship of contours. Okay. Yeah. So because we know the build direction, so we can say this is we use the ray shooting technique. That is, we will be seeing these objects, or we will try to visualize this object in a layer by layer fashion when we are viewing from the direction of build direction. Okay, so if you see this data, these contours layer by layer, what you will notice that you will have C1 contour. So C1 what is the you know C1, this rectangular blocks will be there. Then above it you will have one one object, or one layer which is corresponding to this and corresponding to this. Okay, so there you may find different kind of relationships, like external and contours, different types of contours, like C1 contour is what kind of contour? It is external contour. Okay, so there is no material outside this contour. Okay, so that is why we are saying this is external contour. Okay, when if there is no material inside this contour, then it is called as internal contour. Okay, so C1 is your external contour. Then again C7, your C7, again this C7 is your external contour, right? C1 is your external contour, C7 is your external contour. Then other kind of relationship may be external and internal, like C1 is external contour and C4 is your internal contour. Okay, again C5 is your internal contour. Then there may be another kind of case like internal contour, like for uh, the contour which are C4 and C5, all these are internal contour only. Okay, and again C3 is your internal contour, C2 internal contour, C6 external contour, right? C7 external contour. So this way we can identify which contour is external contour and which contour is internal contour. Okay, so uh, let us move ahead, that we are having an unorganized collection, because here there are, you know, very few contours, so we can easily identify, or we can easily organize these contours in the required sequence. But if there are, you know, multiple number of unorganized contours, call them as collection of bound contours C in 2D space. Okay, so this may be given as C equal to Cx. Okay, so these you can say these are the contours corresponding to your say for values x equal to 0, 1, 2, 3, 4 up to I point. What you need to do, you can say, suppose there may be, you know, multiple points in a particular contour, like for C1 there may be points x1 y1 x2 y2 x3 y3. There may be some different points in one contour. Similarly, the case may be with another contour. So we can say or rather than saying, we consider two contours like Cx and Cy. Okay, and we need to identify what is the relationship between these contours. Okay, so what may be the, you know, possibilities, uh, like one is C1 and one is C2. Okay, so what may be the relationship, whether C1 may be son of C2, okay, or C2 may be son of C1, vice versa, whatever may be, you know. There may be parents a relationship also. There is another case, they both may not be related. Okay, like C1 is nowhere related to C2. So how we will identify whether the two contours like Cx and Cy are related or not, or who is son and who is parent of the corresponding contour. Okay, so for this, what we have to check, Cx is said to be contained in Cy if any arbitrary point in Cx is contained in Cy. Okay, so if any arbitrary, it means all the points in Cx is contained in Cy, then we can say Cx is contained in Cy. Okay, or you can say Cx is son of Cy. Similarly, the vice versa is also true. Okay, so here we are saying Cy is then put in the parent list of Cx. Okay, so this way we will be doing the hierarchical sorting in the case of when we are having multiple contours in a layer. Okay, yes, so that this case we have discussed that Cx may be contained in Cy, is contained in Cx. This may be second case, and other case may be they are not connected with each other, they are independent contours. Just a second. Okay, so I hope my voice is reaching, because there was some network glitch. Students, can you hear me? So this case, let me repeat because I'm not sure whether I was audible or not. So there may be, when we are seeing two contours, the case may be like previous Cx may be in Cy or Cy may be in Cx, or both may be interrelated, not related, or these both contours may be independent. Okay, so uh, these these this way we will see the different contours in a sliced data. Okay, so what in the case of like in this example, because C1 is parent of which contour? C2, C3, C4. Okay, this is parent of these three contours, C2, C3 and C4, because all the points of C2 are lying in between C1. So obviously C2 is son of C1. Similarly, same is the case of C3 and C4. Again, there are relationship between C3 and C4. All the points of C4 will be lying inside your C3. So in C3 and C4, who will be the parent? C3, obviously C3 will be the parent. Okay, so let us take only these two contours, that is parent list of C2. If you want to see the parents of C2, who are the parent? C1 is the parent of C2, and you will give some level number. Say in starting we are giving level number of uh, level of C2 as 1. Okay, let us move on. The parent list and the level numbers are then used for generating the hierarchy sequencing. Okay, all contours are grouped according to their level number. So I will take one example, then you will be able to visualize. Okay, so in this particular it is again very small example. Here we can see, suppose because we are considering as C1 as external contour. Okay, so C1 is the first contour in this particular data layer or sliced data. Then we have who are the parent, who are the son of this particular contour? C2, C3, C4. Okay, so we can say because in this hierarchical searching, what we have to do, we are supposed to find the parent list. Okay, so when we are saying parent of C1, uh, this contour, then parent of C1, who is parent? Nobody is parent. Okay, 0, or we can give it as level 0. For C2, we will see the parent list. Who is the parent for C2? For C2, parent is C1. Okay, we will increase the level by level 1. Suppose level 1. Okay, let us not talk about levels right now. Okay, it is written, then we can write for convenience, so that it will be discussed. Even it will be discussed further. Okay, then for contour C3, who is the parent? Any student, can you answer? C2, C1, only C1 is parent. Okay, C1, C2 is independent of C3, so only C1 is parent. Then for C4, who is the parent? C4, C3, right? For C4, C3 is parent, and before that, who is parent? Again, C1 will also be taken. Okay, all okay. Parent, it means grandparent, grandparent. Everybody will come. Okay, in the parent list. So C1, C3, both these will be parent. And what we are supposed to do, because we are supposed to increase the level only when we are using any contour with previous level. Okay, so what is the level of C1? Level of C1 is 0. Okay, so then we have to increase the level, that is level 1. Again for C3, what is the level of parent? It is 0. Okay, increase the level of parent, it will be 1, right? For it, what is the highest level? C1, C3. Which one is having a level? Highest level? The highest level is level 1, because for C1 level is 0, for C3 level is 1. Okay, and we need to increase by 1 value. It means the highest value 1 plus 1. So this will be level 2. Okay, so this way we need to sort, or we need to set the hierarchy of these multiple contours. Okay. Okay, I will take one more example, don't worry. Yeah. So at level 1, how many contours are over there? At level 0, C1 was there. At level 1, C2 and C3 were there. Okay, this has been grouped like this. Okay. Then at level 2, how many contours are there? C4, only one. At level 2, only one contour is there. Okay, so this way we need to uh, decide the hierarchy sorting for or hierarchy sequencing for the different contours. Okay, this is again in the form of algorithm, how we need to you, we need to identify the parents relationship, or the hierarchy of for the collection of contours. Okay, so how we will start, because in this simple case it is looking well organized, because in this case we are having only 1 3 4 contours, but in actual case there will be a lot of a group of contours, and all these will be scattered in a arbitrary manner. So then how we need to sort out, okay, how we will identify that which one contour is having which level number, and how these contours should be connected or grouped for that, saving this data in the computer memory. Okay, so these are few steps that we need to consider. That is, start forming the sequence by selecting one member from the group 0, then put in the final sequence. Okay, we will try to discuss by taking one more better example. Okay, find its son from the member of level 1. If son is found, it is attached in the final sequence, then the level number is increased by 1. Like in the previous case, what we have done, if I have found the son from the previous list, okay, son from the member of level 1, if son is found, it is attached in the final sequence, and the level is increased by level number is increased by 1. If there exists any contour in the new level, the search continues for its son. If there are no contours in the new level, or if no son is found, the search step back to the previous level and repeat the process until the final sequence is completed. Okay, yeah. Okay, so yes. Okay, so let me take this example for more clarity, so that because here how many contours you can see, there are C1, C2, C3, C4, then C5, C6, C7, C8, C9, C10, C11, C12, right? So there are 12 contours in this particular example, right? So what is the first exercise we are supposed to do in hierarchy sorting? We are supposed to find the parent list for each contour. Like for the case of C1, let me say contour, then here we will write parent list. Okay, or we can write here. suppose we are finding parent or contour. For which contour? C1. Okay, so for C1, who is the parent? Nobody is parent, so we can say level 0. Okay, again, what is the level? Let me write here level. Okay, so for C1 there is no parent, so we can say level 0. For C2, it means for this particular, who is parent? C1 is parent. Okay, and obviously the level will be 1. Okay, because we need to increase the level of this son. Okay, so because sorry, parent. Okay, so what will be the level for C2? That is son of C1. This level will be 1. Then we have C3. C3, it means this contour. For C3, who is the parent? Again C1. Level again 1. C4, parent C1. Level 1. I hope all of you are able to follow up to this. Okay. Then next contour C5. Who is the parent? For C5, C1 and C2, right? Parent and we can say grandparent for more clarity. Okay, so C2 and C1. What will be the parent? What will be the level? We need to increase the level because C2 is having. Uh, just a second, I have one important call. Just a second, give me 1 second. हाँ, क्लास ले रहे हैं ना, पता तो था तुम्हें। क्लास नहीं है, फ्राइडे ना आज। ठीक, हाँ क्लास चल रही। Hello, students, can you hear me? Just confirm because I am connected through mobile. Can you hear me? Yeah, fine, thank you. So for C5, we what is the uh, uh, for C5 parents are C1 and C2. Okay, and what will be the level? Level will be, because the parent is already having level, how much? Level, parent is having level 1. Okay, 0 and 1. So now we need to increase the level by 1. So level will be 2, right? Then it comes to C6, next contour. So for next contour C6, who are the parent? C1 is also there and C2 is also there. Level would again remain the same, 2, right? For C7, any student, who are the parent? C1, C2 as well as C6, right? What will be the level number? 3, right? So I guess all of you are able to understand this parent sum relationship and how do we are increasing this level number. Then for C8, okay, so let me show it instead of wasting much time. I hope all of you are able to follow this process. Okay, so for C8 we have parent C1 and C3. Then for C9 we have parent C1 C3. For C10 again we have parent C1 and C3. Okay, so up to this point I hope all of you are able to follow. Then we need to see this C11. For C11 parents will be C1 C3 and C10, and level obviously it should be increased by 1 because C10 is there. Okay, and C10 is having level number 2, so it is level 3, right? Then it is C12, how parent parents of C12 are C1, C3, C10, C12. Okay, so by hierarchy sorting, or by parents or relationship, we are able to identify the final sequence, or how we are writing this final sequence. Any student, can you guess how this final sequence has come? Okay, so let me draw the parents and relationship again, because we have parent. Who is parent? Highest level, or the lowest level, 0, C1. Then its son are C1, sorry, C2, C3, and C4. I hope still till now you might not be able to write this final sequence. Okay, so that is why I am drawing this family tree. C1, it is having 3 sons, C2, C3, and C4 direct. Then C2, C2 is having sorry, yes, yes. Then C2, in C2, C2 is parents for, C2 is parent for C5 and C6, C5 and C6, right? And C6 is parent for C7. Then try to see C3. C3 is parent for 3 component. C8, sorry, 8, 9. I'm not writing C directly, I'm writing number. Okay, then 10. And then 9 is not, again 9 is not having any son, 8 is not having any son, but 10 is having son. Okay, 10 is having son. What is the name? 11, right? Then we have son. Son of 11 is 12. Okay, C12. Okay, so then C4 is not again having, again is not having any son. Okay, so this is level 0. All these are let me choose another color for more clarity. Okay, so all these are at same level. C1 is having level 0. Then we need to group all the contour with the same level, that is C2. It is corresponding to level 1. It is corresponding to level 1. Then we are having another set that is corresponding to group number 2. This is corresponding to group number 2. Then we are having, or group number 2 or level number 2. Then we are having another set. This is corresponding to level 3. Okay, then we are having corresponding to level number 4. Okay, so this is how we can write the level number of these parents and relationship. And let me solve it again. Yes, yes, let me read it again. If there are no contour in the new level, uh, if there exists any contour in the new level, search the search continues for its son. If there are no contour in the new level, or if no son is found, the search step backs to previous level and repeat the process until the final sequence is completed. Okay, so yes. Okay, so now we can write the sequence. What will be the sequence? C1, then C2, it is there. Then it will come to its son. First we will try to complete one family tree. Okay, so C1, C2, C5. After C5 we will go to again here, and it will be C6, C6, C5, C6. Then from C6 it will come to C7. Okay, so this first one arm is completed. Okay, you can say one set is completed up to this point. Then it comes to C3, 8, 9, 10, because 8, 9 are not having any sun, so 8, 9, 10, 11, 12. C8, C9, C10, C11 and C12. Okay, completed up to second arm, you can say second family tree completed. Then it comes to third contour, that is C4. Okay, so then C4. This way we need to sequence this. Uh, uh, we need to sequence these contours in this particular final sequence. Okay, so the final sequence is already written here. Maybe before sequencing, you might have wrote them in this format like C1, C2, C3, C4, C5, C6. But the final sequence will be C1, C2, C5, C6, C7, C3, C8, C9, uh, C9, C10, C11, C12, and C4. Okay, so this is how your your hierarchy sorting is done. In hierarchy sorting, we are arranging multiple level contours in a appropriate sequence for the layer. And in the case of contour sorting, what we are doing, the next step is to arrange the contour at the same level. That may be that may be random. Okay, the contour with the same level may be arranged according to their minimum and maximum x and y value. If the two or more contour bounding blocks overlap, the original sequence will be used. Okay, so this you can also practice the you know different uh, 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 sliced model. You can try, you can search a few problem from the Google. And for today, I think I will stop here, and we will continue the rest part in the next class on the Monday. Okay, if there are any query, we